Hey everybody, thanks for coming out to my talk. Apologize, I think the fonts got a little messed up on my slides when I exported it to PowerPoint, so the design team will be angry at me. So I'm gonna talk about how we're using Redis to power our geofencing feature. It's something that we started development on in last October, and I was the primary backend developer for it. Yeah, so I'm from Appboy. We're a mobile marketing company. What that means basically is that we give you a view of your users that can be across different apps they may have with you, across their email, across their websites. We give you a consistent view of your users so you can segment them, learn things about them, message them. We support email channels, push messages on phones, things like that. So when we're building things at Appboy, it's a big word at this conference is scale. We operate at very large scales. Our SDK is installed on over 1 billion devices. We have a web SDK that I'm not sure, that's pretty new. I'm not sure how many sites that's on yet, but we just have, we have a lot of data coming in. We work in a multi-tenant databases because we have customers across different, we have like travel apps, like ride sharing, food delivery, some retail locations, that type of thing. So we have a wide variety of customers and they have a lot of users. We wanted to add geofences to our offerings so you can learn about your customers based on how they're moving around. We had one location feature that didn't involve geofences. It was, when you start a session with our SDK, it would update where it would query the device to figure out where the user was with the lat long, and we would store that, and you could message based off of that and look at your users based off of that. That was never too popular because of all the different permissions that it required people to allow the app to do for us to actually be able to do that type of monitoring. With geofences, actually, I go to the next slide. They're built right into the SDKs. Yeah, so they're built right into the SDKs, so you don't need as many permissions when you're trying to query geofences. So a geofence is a point in a radius, basically a circle on the Earth. And the SDK, so the two SDKs we're talking about, or the two platforms we're talking about, are Android and iOS. They have native support for monitoring these things. They can give you events when you walk into a circle, when you leave a circle. There's support for dwell time. That's pretty straightforward in Android. It's not as straightforward in iOS. We actually haven't done that yet. I think I have a later point about that. So basically, they tell you like where a person is. You can like, if you're a retail outlet, if you're selling coffee, you can put a geofence around your coffee shop, and the phone will ping the Appboy SDK when somebody comes near your coffee shop. If you're having like a relay race or something, you can set up a geofence at the starting line and tell people like it's time to register for the race, that type of thing. Okay, so like I said, we're trying to support Android and iOS. So our SDK contract, that was kind of the first thing we worked out. So we wanted to support basically the lowest common denominator of iOS and Android for all the major features. There are some different configuration options. The main one I think the main one is there's a configuration option, and well, I guess there's one in iOS too. Basically, a configuration option on how aggressively the phone will check for how often it's moving. And that's kind of like a battery life knob. But for the most part, the features we're supporting are, do we want to monitor when you enter a geofence? Do you want to monitor when you exit the geofence? Because you can set those permissions separately or those events separately on both iOS and Android. And okay, so that's what we're doing. We're just supporting enters and exits. We're not worrying about dwells at the moment. So the SDK, when it talks to our API, what it's asking for is it wants to get the 20 closest geofences to a device's location. So it does have to figure out where the device is initially, at least. The reason we chose 20 is because iOS allows monitoring up to 20 geofences per app. On Android, it's higher, it can be up to 100. Android's a little strange because I'm not the Android developer, but this is just what Jared, our Android developer, has told me, is that it will let you like register, but it doesn't really tell you like when it's pushing out other things. So we didn't think pushing up towards that limit was worth it because it's just too hard to tell like what exactly the SDK is doing. And iOS only supports 20 anyway. Okay, and then we're defining closest to be the distance to the edge of the geofence. So say you had like 500 geofences at all your retail locations across the United States. If you're in New York, which is where Appboy is based, maybe there are 30 in Manhattan. We want you to just be monitoring the 20 that are closest to you because those are the most likely ones for you to go through. And closest being defined by the edge of the distance to the edge of the geofence. I'll go over that up a little bit more later. Yeah, and so that's what the SDK is looking for. So what the API needed to do, it needed to be fast and scalable. We're not looking to do dynamically updating of geofences like on a device while a user's moving around. So in my example about Manhattan, there's like 30 locations, you're starting lower Manhattan, you move to upper Manhattan. We're not like hot swapping out the geofences that a device is monitoring, at least not at the moment, because we couldn't figure out like a great way to solve the problem of figuring out when the device has moved far enough. But that's a little bit about on the mobile developers. They kind of came to that conclusion. It wasn't really my decision on that part. So we will resync geofences when you change them on the Appboy dashboard. So a marketer comes into our dashboard and defines geofences. We have a nice little interface built on, what is the, well, I have a slide later with a picture of it, so I'll tell you which open source platform we built it on. But OpenMap, I think that's the name of it. So yeah, so you can go on there, you can draw your geofences, you can also bulk upload them with GeoJSON. And so what we're expecting, at least from our users or from our customers, is that they're not like constantly updating their geofences. This is just kind of a trade-off we made in our design. And because we're not like hot swapping geofences out, that's probably not like a huge limitation. I mean, the hot swapping is probably the bigger limitation. So we will resync geofences when people edit things on the dashboard. And we do that by sending a silent push to users' devices. And so we try to, when we do that resyncing, we try to spread it out, but some of our customers have lots of users. So we do need the API endpoint that returns the geofences to be pretty performant, because a lot of people could be pinging it at once. Okay, so just some quick reasons for why we're using Redis. So we already use Redis in lots of ways. Our primary data store is Mongo. We like Mongo because it helps a lot with our our segmentation capabilities. It's really easy to just like define a segment by setting a bunch of fields in a Mongo document and then matching on those fields. It's easy to write those queries. Well, relatively easy. But we do have problems with overloading it. So we try to cache aggressively. We use Redis for a lot of that caching. We also use memcache. Basically, any sort of queries like so the way the Appboy dashboard works is you can define campaigns. You can send those to like a segment of your users, like when they either like on a set schedule or when they do an action. So anything we can cache, like what are the rules for segment membership, who's in a segment, what are the campaigns a user's eligible for? We try to cache those in Redis whenever we can. We also use Redis for things like distributed logic and rate limiting. The CTO of our company, John Hyman, he gave a talk last year about that. We'll also use it for a state machine and our Canvas feature. Canvas is, I don't want to turn this into an Appboy commercial, but Canvas is basically a way of defining a flow of messages that a user can go through. So like your user onboarding process, for instance, like you send them a welcome email. If they haven't like responded to that within a week, maybe you send them another one. Maybe you send them like 10% off after like a certain time. So you can define those types of rules in Canvas, and we use Redis to implement that sort of state machine. We also use it for caching queries that we're going to write to Mongo. So like when users update their profiles, like say you send out a push message to 10,000 users, 5,000 people click it. We want to keep analytics on how many opens the push got. We don't want to write 5,000 individual writes to Mongo. So we push those into Redis with like anchor commands, and then we have a job in the background that runs on Sidekick that will bulk write all those updates at once. Yeah. So the way we're using Redis for geofences is when a user's device makes an API request for the geofences around it, we'll push them into our Redis stores. So if it's less than 20 geofences, so we can so app groups are how we like organize things on people's dashboards. If you have multiple apps, they can be in a single app group. It doesn't have to be an app. It could be like your website, that type of thing. So when an app group has less than 20 geofences, we just send them all to the device. That's in a simple, our pattern is basically, we have local caches, local machine caches are in Redis, and network caches are in memcache. So we'll check like the network cache, then we'll check the local cache and move them in that way. When there's more than 20 of them, we push them into a geospatial set. Okay, so Redis Geospatial support. This was added in 3.2.0, which I think came out about a year ago. It's built on top of sorted sets. It uses a z-curve to map 2 dimensions to 1. So if you know the properties of sorted sets, you have a score and you have the value at that score. So a score is 1 dimension. It's just one big number. A lat long is obviously 2 dimensions. It's 2 numbers. So you have to make that lat long into a single dimension. And you do this using a thing called a z-curve, which I'll go over in a little bit. Then you use the georadius command. It returns all the points within a certain radius in that sorted set. It's implemented using a bunch of z-range commands. So if you know the properties of z-range, then georadius gives you the same properties. That's one reason we were confident in using it, because we use sorted sets all the time at Appboy. So we know that they perform at the scale we need them to. Yeah, if you're not familiar with how z-range works, the performance is big O of log n, where n is the number of elements in the sorted set, plus m, which is the number that are within your query. And so the georadius is not just one z-range command, it's actually could be up to 9. I'll go into why that is in a little bit. Geoadd is the only other spatial command we're using. It's implemented like zadd. Basically, it turns your lat long into a geohash, and it zadds it to the sorted set. There are other commands for geospatial. Those are the only two we're using at the moment. When we want to poison the cache, get rid of the stored geofences, we just use a zrem. That's I don't even think there is a special command for deleting from a sorted or deleting a key. Because so when a customer updates, we just delete the whole thing. We don't try to like individually pick out one geofence because we just think updates aren't going to happen that often. That type of optimization is not really worth it. So let me just get into geohashing a little bit. So the way it works is this is just this little SVG I just made. There's a couple websites that have more beautiful pictures, but I just wanted to make one of my own. So it splits up. So if you think of like going down as the latitudes, going across as longitudes, it splits the space into 2 in each dimension. And so the leftmost bit here, that's like the latitude bit. So on this side, this is the latitude bit. So on this side, it's 0. On this side of the line, the most significant bit is 1. And so 0, 1, 0, 1. So the red bits here are going in the Y direction. The green bits are going in the X direction. So you just split it up into 2. So if things share a common prefix, that means they're up to like whatever resolution the prefix is representing. That means they're near each other. But things that aren't, just because they don't share a common prefix doesn't mean they're not beside each other. Like so pretend that this is the prime meridian. I'm not exactly sure the details on like where Redis like splits everything. So there's a geohash.org, I think, will like turn your thing into a nice string characters. Redis doesn't, I don't think Redis uses that directly. It actually does some like floating point arithmetic, and it actually doesn't work around the poles either because I think the reason they do that is because of the distortion of how long it is between latitudes as you get further and further north, because the Earth is a sphere. It's not a flat plane. So basically you just split the space in 2, and then you interleave the lat long bits basically. So that's how you go from the 2 dimensions to 1 dimension in a Redis sorted set. So when we're doing geofences, we need to go back from 1-dimensional points to from 2-dimensional circles. So when we do the georadius, after that we're not actually done. We have to massage the data a little bit. So we store the radius as supplemental data. In our case, the geofence data, it's all a JSON encoded string because that's what we're pushing down to our SDKs. So we just pull it out of the result. So then you have to be a little bit careful if you're doing geofences that are like of much, like if some are much larger than others, because you could be closer to one with the edge of one with a large radius, but Redis tells you the difference is really far because it's just looking from the center point. So when we get it back, we have to like reorder them by subtracting off the radius, flooring at 0 in case you're like inside the circle. But even with those caveats, Redis is still right for our use case. It doesn't add complexity to our build because we already use it, and we can work around the limitations of the georadius. When I was writing the code for this, we hadn't actually upgraded Redis to 3.2 on staging or on our production servers yet. So I actually wrote, so for our internal beta, I did all the queries in Mongo, which also doesn't do circles. I had to do some massaging of the data there too. It does do, it does GeoJSON, which GeoJSON just is the concept of a circle. Yeah, so okay, let me give you an example of what I meant by you have to be careful about the circles. So here's Lower Manhattan. Here's the geofence around Gramercy. This is a geofence around Soho. So if you're like in Washington Square Park, I didn't actually calculate the exact distances, but you could imagine that like this point in Washington Square Park is closer to the center of the Gramercy geofence than it is to the center of the Soho geofence. Probably not actually, but so that's the kind of, and so pretending that you can only store one geofence on your device, you probably want to store this one. So that's why we have to be careful about those edge cases. It also means that you have to, so if you want like all the geofences within, or if your like max search range is like 100 kilometers or something, you have to actually search 100 kilometers plus the maximum size of any geofence in your georadius command because of that like edge case. That's not too big a deal. We actually don't, we have like a max geofence size that's based off of Apple and Android's, Apple and Google's recommendations. We don't like store like what the actual maximum a customer's used. We could do that. We just use like whatever our like actual or max that we allow is when we do the queries. Oh yeah, so it's OpenStreetMap. That was the software. Mapbox. That's the software we built the dashboard component of this on. Okay. So that's how we. Yeah. So that's how we actually do it. We cache the geofences where we push the geofences into Redis, and we do all the queries in Redis. The first approach I took to this was doing the query in Mongo and storing the results in Redis, and basically I was storing a radius for like which these like if a max radius for which these results are still okay, they're still valid. So it would look like for the distance for the next closest geofence. So like if you were farther away than that, then you would have to query Mongo again. Yeah, and then so you do a georadius with a fixed size. It's counted as a cache hit if it's within the one of the results is within the valid radius. We dropped that approach for complexity. Our customers are heterogeneous. We don't really know exactly how they're going to be using geofences yet. So we just went with the simpler approach where we just push everything to Redis, where we're pretty confident in their performance, and then we don't have to. Basically, we're just using Mongo to like just dump data into Redis. Okay, so a little more details about how we actually do this. We use multiple Redis shards. We use consistent hashing to like figure out which shard for. It actually depends on what type of data we're caching. But in this case, we actually just push it to every Redis shard just in case. Or to every Redis box. We don't really do any sharding with this because, just in case a box is down and there shouldn't be like a ton of data here. So yeah, we have different Redis boxes and different AWS availability zones. So we just loop through all of them and geo-add when there's a cache miss. Yeah, on a cache hit, we look for the geofences within the search radius, plus, like I said, plus the maximum size of a geofence. So that ensures we don't miss large geofences when we're doing our queries. And then on an update, we just delete the whole Z set. It's because we're thinking updates are going to be rare for how our customers are going to use it. And if that is the case, then the overhead from that is low. If it's not, then I guess we'll have to iterate on how we're doing that. Yeah, and I guess I kind of went through this too. When so building the result, we stored it in our application code. Our application's written in Ruby. So we asked Redis for so we do get the distance back from Redis, from the center point in Redis. I guess you could do that calculation on your own in Ruby, but it's probably faster, almost certainly faster to do it in Redis. And then we have to like hydrate the JSON string to figure out the radius and subtract it off. So this is something that I haven't implemented yet, at least not in Ruby. We could, you don't actually, so we do, currently it does sort the whole like result set. You don't actually have to sort the whole thing. You could just pick out the 20 closest, and I actually don't know if this is the optimal algorithm to do it, but it's the one I thought of. You just like build a max heap and delete the, so like you insert the first 20 and then just like insert and delete for the next 21 plus however many there are in there. And if I did my math right, the performance of that should be big O of n log k, where n is the number in the result set and k is the size of your of how many you want. Hopefully I didn't embarrass myself with the math there. But obviously sort of the whole thing is n log n. That's probably not an optimization we need to do at the moment, but it's kind of cool to think about. The biggest thing that's probably the issue with our API endpoint is we do lots of serializing and deserializing of these JSON strings. We could definitely cut down on that, but probably not without like changing like how some of our API abstractions work. But I guess we'll have to wait for it to like actually be a problem before we start doing stuff like that. Okay, so, and I'm just going to talk really quickly about I actually built a Redis module as a Hack Day project. We had a Hack Day thing at our office. We do it about once a year, I guess. So I built a Redis module, which is actually not that bad. The hardest part was getting the makefile to work. And some of the documentation I was using was outdated. I just looked at the Redis source code though, and it's pretty easy to figure out what it's well commented, and even when it's not commented, you can just figure it out based off like variable names, like what you need to pass in. For the georadius commands, so when you build a Redis module, you can it's not just like doing a Lua script in C. You can actually get internal data structures from Redis. You can get like with like a Z range, you can get a cursor, and you can just like ask for the next value from the cursor. You don't have to like import the whole result of the Z range into an array and work on it. Unfortunately, with the georadius, you actually do have to do that. So it's actually not that much different than writing a Lua script in C. I didn't actually try it in Lua. I imagine it's probably not. Maybe it's a little bit, probably my module's a little bit faster than writing in Lua. I don't actually know. I should try it sometime and figure it out. When I did it in C, I actually did do the max heap idea. And just from my testing, which I probably should have made a results slide about this, but I didn't. If you really care, you can sit down and I can compile it on my computer and we can go over it afterwards. I did see some improvements. I was doing it in Ruby just because that's the language we use. The Ruby Redis module actually doesn't support Redis 4.0 yet. So I actually had to write some of my own like Redis communication code, which is actually not very hard. Like it's a really easy protocol to understand. If you're, you can just, if you're ever curious about it, you can just tell that onto a Redis box and start entering commands. It's not that hard to figure out. That was a cool project. So if you guys are like scared of modules, it's really not that bad. I hadn't written any C since college, and I didn't have too many problems with it. There were some. I did crash the Redis server quite a few times, but it was just running on my box, so it didn't matter. That was everything I had. So if you guys have any questions.
Yeah, so I understand calculating the geofence. I just don't understand how an advertiser would use that. Do you have an example of how they would use it and what they're calculating the geofence against? Is that the individual devices? Or what exactly?
Like some of our use cases that we've thought of that I think some of our customers, it's all in customer beta right now, so we don't really know how they're going to use it. Like, you could put a geofence around an airport, and when like somebody arrives at the airport, you could tell them that, you know, you can check them through your flight using the app on your phone. You could put a geofence around, like if you have like an event like a relay race or something, you could put a geofence around the relay race, and if you could like have people check in like through their phones instead of having to like go up to a registration desk, stuff like that. I don't know if people want to like put them around their retail outlets, for instance. Maybe that's a little too invasive for the average consumer. I don't actually know. But yeah, we're really waiting to see how our customers use it more than anything else.
So just so you know, yeah, it sounds kind of invasive for the North American market. But look at South Korea, they already do that. So you may want to look at their use cases and how they're using it now to project how will be invaded in the future, you know?
Yeah.
But in South Korea, for example, if it's raining, they'll send you an umbrella advertisement based on the weather, based on whether you're going on the metro or whatever it is you're doing, you know?
Yeah.
And it is very creepy, but that's the state of the art in South Korea right now.
Yeah, we do have some South Korean customers, so.
Oh, just talk to them.
Yeah.
First of all, just want to say you described the application that I work on. We got Mongo, Redis, Rails, and AWS. So it was just very interesting to hear very similar solutions. I'm curious to hear more about that bulk update thing you mentioned with jobs, because we also use Sidekick, and we get a huge influx of messages when people open our emails. But we just kind of like queue one job per message, which does an individual update to each record in Mongo. And it works for our scale, but I'm curious how you said you do some bulk updates via just batch.
Yeah.
Like, do you put like all the message IDs in like in a set somewhere, and then every 5 minutes the job grabs them and does a bulk update to Mongo or something else?
That's basically how it works. I didn't write that code. I've written interfaces to the code, but I haven't actually written that code. But it is something like that. We store things in sets, and then we just schedule a bunch of jobs that will read X number of values from the set and run it.
But you always get one message per unique ID. You don't have like a situation where user ID 123 did two things.
We try to, we'll only send it to one. For this, we're talking about push tokens, because we're like sending it to, so we're sending a silent push to a user's device that says like reping our servers. So we do unique on the push token for this. And when we send email, we try to make it unique on the email address too, because the user could have multiple. So we don't do it on user IDs, we actually do it on push tokens.
Yeah. So then this set just sits in Redis and has got the first 100 users that open the email or whatever, and then the job grabs it, grabs all those set members, aka user IDs, does a bulk update.
Yeah, yeah, that's pretty much how it's done.
It's nice that people do similar stuff.
Yeah, it's cool.
You mentioned that you have like your SDKs on 1 billion devices. Is that, well, first of all, that's really big. Is that like evenly distributed around the world, or like how, like obviously that can't all be in the United States, right?
Well, so I think that's including like, we could be on a device multiple times.
Okay.
I'm not really sure where that number comes from. That was just the number I was told to use. So.
Okay, well, it's a very big, impressive number.
But I do think that's including like, because we could be on like 4 apps in a single phone or something. So I think that's including like.
Oh, okay, that makes sense.
Yeah. And most of our customers are US, Europe, and we've been expanding to Asia a little bit too.
So they link Appboy with their app, or how is it distributed?
Yeah, like we store the data on our servers, and you can like query our servers for like export and stuff like that.
No, but how does the SDK get on the device?
Oh, the developer has to embed it themselves. So.
Okay, so you link to a library or something.
Yeah. We have an Appboy library.
Yeah, there's some apps that link to everything, so it's like 12, 15 libraries. I mean.
How are you organizing your keys, I guess? when you ask for a particular device, are you just getting the app that they're in, geofences, or are you getting?
We're not doing like per app geofences at the moment. It's just, so we have this thing called an app group on our dashboard, so you could have multiple apps in that. I think a lot of app groups just have one app in them. So so you define those geofences, and those go to any app that has geofencing turned on. We'll get those. Yeah,
Okay,
so like
for
each
one
app group. Sorry.
So for one call, you would get only the geofences for a particular app group.
Yeah. Not like everything across every customer. Just
okay.
just all the geofences for one app group. So for one customer.
Okay.
So do you have a situation where you have to handle polygon-based geofence, or it's always radius?
I think the devices themselves only have maybe Apple. We're only doing circles at the moment. Yeah, we don't put polygons at the moment. Our old location offering actually did do polygons, but that wasn't very popular. So, but yeah, so we're only doing circles, not polygons at the moment.